a great resource. Welcome back to another Simply EDU video. And in this video, I'm going to be talking about how to get an 800 on the digital SAT math section. So here is our video outline, and I know I didn't include it on here, but first I'll talk about my prep really quick. So I took the May digital SAT and I got a 1600, and before that I took the August paper SAT and I got a 1570. And on both of these tests I had an 800 on the math section. Along with that, I took the PSAT back in October and I got a 1520. Now, as you can see here, first I'm going to do general strategies, then all these topics you can see here, and at the very end, and in the second part of this video actually, which I'll upload after, I'm going to do a walkthrough where I'll go through module 2 of practice test 5 or 6. We'll see which one I do when we do the walkthrough. Now, one thing to keep in mind here is that I only did 4 actual topics in this video, and I know that they definitely cover a lot more on the SAT. But the reason that I'm not going through every single one is that a lot of these are not topics that I can really explain well and give a whole, dedicate a whole slide towards it. It's better to just see me do the question, because that's how you can see me really approach the topic and how I think towards that. So if the topics that you're struggling with are not included on here, then make sure to go check out the walkthrough, because in that I'll do all sorts of questions. So first, for some general strategies, the main thing is to take Algebra 2. Now, in the ACT you had to go up to pre-cal. With the SAT you don't need to do as much. You just have to take Algebra 2 and you really should know all the math concepts that are on the test. There might be some more that your algebra class does not discuss, but for the most part, Algebra 2 will let you get all the math that you need to know. After that is just a very common strategy, and that is to plug in the answer. A lot of the time, if you really don't know how to do a question, or even if you do but you're low on time, one way to get it done really easily is just to plug the answer choices back into the question. Now, this isn't always applicable, but in the cases that it is, it really does help out. And the third and final tip is to use Desmos. Desmos is such a great resource. It's, I would say it's even better than the handheld TI calculators, in that you can type in all sorts of functions on there and it'll graph it for you and make any question really easy to visualize. And you know what, I'll add a fourth tip into here too. This doesn't really work as well as it does for the reading and writing section, but that is just another guessing strategy for multiple choice questions, and that's that you should have a relatively equal amount of A's, B's, C's, and D's throughout your test. And so if you're really struggling with the question, you just don't know how to do it at all, then try to pick the choice that'll make the number of A's, B's, C's, and D's that you've picked throughout the test equal, as hopefully that makes sure that your guess is correct. So now let's get into the first actual topic, function basics. First is plugging in values. And really this is just pretty standard, right? If they say f of x is equal to x squared plus 2x, and then they want you to find f of 2, then you just plug in 2 into every place that you see an x. So in that case it'd be 2 squared plus 3 times 2, which is 4 plus 4, so 8. And then next is factors and zeros. So a zero is the x-intercept of the function. In other words, when the y value of the function is 0, that's what they call it, a zero. So a factor is basically whenever you have all the factors of a function, you multiply them together, that's when you get the actual function. So let's say that my factors are x plus 1 and x plus 2. Then the total function would be, when you multiply them together, x squared plus 3x plus 2. And it's in these factors that you can see the zeros of the function. So for x plus 1, if that's a factor, then x plus 1, you have to set that equal to 0. Then x equals negative 1 is one of the 0. What that means is, if I plug in negative 1 into the function, then the value of the function is going to be 0. You'll see more of this when I actually go through some of the questions. Next is the y-intercept, and the y-intercept is the value of the function when x is equal to 0. So don't just pick, I know a lot of the time what we do is, if we're rushing, you will see a function let's say y is equal to x minus 3 whole squared plus 7, right? You might be tempted to just say 7 is the y-intercept because it's the constant term, but don't do that. It's specifically when x is equal to 0. So if you need to find a y-intercept, plug in 0 into the function, and that's how you'll get it. Next is increasing versus decreasing, and this is pretty standard. Just over a given interval, if the y values are increasing, then the function is increasing, and if the y values are decreasing, then the function is decreasing. And finally is how to interpret parts of a function, because I've noticed that they've asked this a lot more on the digital test than they would in the paper test. And really what you just have to know is what each part of the function represents. The y-intercept almost always just means like the starting value or the principal amount. So if you're in a linear, let's say you have a linear situation, right? And it's that you have a tub of water and you're pouring in water over time. And let's say that there already were like 2 liters of water in the tank. And then every minute that passes by, you add a liter of water to the tank. Well, your y-intercept would be 2, right? And that's your starting amount. Then the total function would of course be y is equal to x plus 2, where x is the amount of time and y is the amount of liters in the tank. So again, 2 being your y-intercept represents the initial amount of water. And then the slope, which is 1, because that's the constant in front of the x, represents the rate of change. So they asked, what does the 1 in front of the x mean? Well, that means the rate of change in the volume of the tank over time, right? The rate of change of y over x. And that's really it. In exponentials, you'd have to interpret the rate slightly differently. So let's say you had y is equal to 2 times 3 to the x. Then your principal amount would be when x is equal to 0. So y is equal to 2. Your y-intercept would be 2. But the 3 would be your rate of change. So that means over every interval of time, or every x interval of 1, y would multiply by 3, or it would triple. So your rate of change there would be 3. And so if you want to say in terms of bacteria, but that means like you started off with 2 bacteria, and then as every minute would pass by, the population tripled. So after 1 minute passed by, you have a population of 6 bacteria. After 2 minutes, you have 18, and so on and so forth. Next is statistics, and they really aren't that rigorous in the digital SAT. You really just have to know these 5 things: mean, median, mode, range, and standard deviation. Mean is the average value of the terms, so you add up all the terms and then divide it by the number of terms. So if I have like 2, 3, 4, 5, I'd add it up. So 2 plus 3 is 5, 5 plus 5 is 10, 5 plus 4 is 14. I'll then do 14 divided by 4. So you would get 3.5 as your average. Then the median is the middle value. So if you have an odd number of terms, then the middle is just literally like the middle term. So if I have like 5 terms, like 1, 2, 3, 4, 5, then the middle term would be the third term. So my median would be whatever the third term is. But if I only have 4 terms, then my middle is both of these values here, the second and the third. So you'd have to take the average of these 2 terms to get your median. Now the mode is just the number that appears the most often. So if my data set is 1, 1, 2, 3, 4, then my mode is going to be 1, because 1 appeared twice while every other value appeared once. Then the range is just the biggest value minus the smallest value, right? So again, for that data set 1, 1, 2, 3, 4, the range should be 4, the biggest value, minus 1, the smallest value. 4 minus 1 is 3, so my range would be 3. And finally, standard deviation. Now, the actual calculation for standard deviation is a little complex, but fortunately, you don't need to know that for the SAT. You really just need to know what it means. And the standard deviation is just how much the values vary from each other, right? So let's say I have a data set, just 1, 1, 1, 1, 1, 1, 1, right? So 1, 1, 1, 1, 1. That's like 5 values, right? And then let's say another data set that goes 0, 1, 2, 0, 1, 2, right? Both of them have the same mean because the average of both of them is still going to be 1. But the second data set has a larger standard deviation than the first data set. And the reason is that the first data set is all 1s. The values don't vary at all, right? On the other hand, the second data set, it's 0, 1, 2. So there's like a good amount of variation there. They vary from the mean quite a bit. So there's a larger standard deviation. In general, whenever you have like more spread out values, there's a higher standard deviation. Next up, we have trig IDs. So first things to know is the definitions, and there's this acronym that a lot of teachers like to use, SOHCAHTOA, to understand them. So for sine, it's opposite over hypotenuse. So let's take a look at this triangle over here. As you can see with my cursor, I have the cursor at this angle between the red side and the purple side. So for this given angle, sine would be the opposite side, the O, over h, the hypotenuse. So green over purple, whatever those respective lengths are. What is this? 3 and 5. So sine of this angle here would be 3/5. Then cosine is CAH, ca. It's adjacent over hypotenuse. So the side adjacent to the angle over the hypotenuse. So this would be, so cosine of this angle would be 4 over 5. And then tangent is opposite over adjacent. So tangent of this angle would be 3 over 4. And then the next thing to know is these, I guess, complementary identities, right? So they don't test this as much as they used to in the paper test. Basically, if you have a given angle, let's say x is like 30 degrees, right? Then sine of 90 minus 30 degrees, so sine of 60 degrees, is equal to cos of 30 degrees. And then if I move it the other way around, cosine of 90 minus x is equal to sine of x. So if I have, again, the angle 30, cosine of 60 degrees is equal to sine of 30 degrees. And of course, if you want to convert this into radians, then instead of doing 90 degrees, you would do pi over 2. Next is the reciprocal identities. So 1 over sine is cosecant, 1 over cosine is secant, and 1 over tangent is cotangent. So if you want to relate this back to the definitions, sine is opposite over hypotenuse, but cosecant is 1 over that, so it's going to be hypotenuse over opposite. Similarly, secant is going to be hypotenuse over adjacent, and cotangent is going to be adjacent over opposite. And now we have geometry. First and important thing is to use the formula sheet. Now, I know a lot of us might struggle with remembering all the different volume formulas or area formulas and things like that. So that's why it's important to look at the formula sheet, because they should have everything on there. Now, because it's digital, you might have to click on like the info section or something. I kind of forgot what that whole platform is like, but make sure to use the formula sheet because it really is very helpful. Next is the surface area formulas, because unfortunately they don't include this. So for a cylinder, it's going to be 2 pi RH plus 2 pi r squared. And the reason is that if you imagine a cylinder, right, so let's say like my arm here, right, I know it's not a perfect cylinder, but let's say this is a circle, and then this is like the whole cylinder. Then if I want to find the surface area, it's going to be this face plus this whole like around area. So the way you can imagine it is that this is going to be the pi r squared, because it's circles, right? So that's why you get 2 pi r squared. And then 2 pi RH is basically because you're going to get the circumference of like these circles and then multiply it by the height to get that full like surface area or perimeter of the lateral face of the cylinder. Now a cube is pretty simple, 6s squared, right? I mean, it's kind of easy to understand. It's just you have the cube, then every face of it is the equal area, so just find the area of one face multiplied by 6. And then a sphere is going to be 4 pi r squared. This one's a lot more difficult to really understand, but just make sure you know that formula. Next are some triangle properties, and the first one is that the sum of all the angles in a triangle are 180 degrees. I think that's a pretty standard one that we all know, but just make sure to keep that in mind because I've seen some questions ask about that. To that end, make sure you know the difference between supplementary and complementary. So supplementary means that two angles add up to 180 degrees, but complementary means that two angles add up to 90 degrees. Then special right triangles, so this is actually very important. So this here is an example of a 30, 60, 90 triangle. What that means is one angle is going to be 30 degrees, another angle is going to be 60 degrees, and then the third angle, or I guess the middle angle, is going to be 90 degrees. So the property here is that the side opposite to the 30 degrees, if we call it x, right, so this is x here, then the side opposite the 60 degree angle is x times the square root of 3. Like the side length is going to be x times the square root of 3. And the hypotenuse is going to be 2x. And one way you can kind of know this is that if you know some of the values like cosine and sine, then you'll understand why this works. And really all of this could also be derived from an equilateral triangle. Like if I were to reflect this across this blue line here and have two of this like back-to-back triangles, kind of like it's kind of hard to model with my fingers, but like you can kind of understand what I mean here. Another green side here and then a second red side down here to fill it out. You'd have an equilateral triangle, and there all the sides are equal. So that kind of helps you to understand why the 30, 60, 90 triangle is the way it is. Next is the 45, 45, 90 triangle. Here's where this angle's 40, this angle's 45, this angle's 45, and this angle's 90. So in these triangles, if we say that this side length is equal to x, then this is also going to be equal to x because it's isosceles. And then the hypotenuse is going to be x times the square root of 2. So make sure you know these specific values because they can really make it a lot easier. And even if you don't, a lot of the time it is still pretty easy to figure these out, but just make sure you know them. It makes it a lot easier. Now into circle properties, the first is Thales' theorem. You don't need to know that it's called Thales' theorem. You just need to know like the actual thing. And that's that if you look at the circle over here, I have a triangle inscribed in the circle where 2 points of the like 2 edges of the circle are, 2 points of the triangle are over there, and the third point reaches to hit the circumference as well. Whenever you have a situation like this length, the hypotenuse of this triangle is going to be equal to the diameter of the circle. And whenever you do have that, by the way, that the hypotenuse is equal to the diameter, then this angle made by hitting the circumference over here is always going to be 90 degrees. That's the important part. This angle is 90 degrees. Next, so kind of tying on to this concept, is when you have inscribed figures, whether it's a triangle or a rectangle inside a circle, make sure to look for radius and diameter, because usually they try to ask you a question that involves like knowing that the radius is always equal, right? So maybe they might like draw a radius down here and then ask you like, I don't know, what's the length of this side, right? So make sure to always think about radius and diameter whenever you see a figure inscribed inside a circle. And then finally is just, 2 pretty common circle formulas, right? The area is pi r squared and the circumference is 2 pi r. And that's going to be all for the content part of this video. In part 2, I'm going to do a walkthrough of module 2. So stay tuned and good luck.